Welcome back from your break. Now let's get into what reactions are actually happening in the electrolytic cell. So here we go. The terms I want to explore and remind you about: when we have an electrochemical cell, the galvanic cell, we had an anode. And we said that at the anode, there is always oxidation that takes place. Remember? An ox. Just an ox was our term that we used. At the cathode, we said reduction takes place. And we looked for the red cat. Now, bear in mind that you need to remember that oxidation is a loss of electrons, where reduction is a gain of electrons. So we remember those terms by recognizing that oxidation is a loss, that mnemonic oil, and the mnemonic here, rig. If you remember these little memory tricks, it will certainly help you to analyze and to recognize where things are happening. So let's apply this knowledge to try and work out which is the anode of an electrolytic cell and which is the cathode of an electrolytic cell. In our electrolysis experiment of copper chloride, we saw the results. We saw chlorine being produced. We saw copper being produced. And remember, we started with ions in the solution. So you started with chloride ions, and there were double the amount of chloride ions, and we started with copper ions. So is this a redox reaction? Well, how can we determine if something is a redox reaction? The first way is to look at the oxidation number. So here we go. Recognize that in this reaction, the elements are always given a unit oxidation number of 0, and the charges are given the oxidation number according to their charge. So look what's happened. We've got copper at 2+, copper to 0. So to go in that direction, what's happened? Well, that's been a gain of 2 electrons. And over here, it went from minus to 0. So I hope you can see that that's a loss of, and there were 2 of them, so a loss of 2 electrons. So clearly, this electrolysis experiment is helping us to understand that it is a redox reaction, just by looking at the change of oxidation number. And it's often a very big clue if you can see an ion changing into an atom or a compound changing into an element. That's a redox reaction. And so bear that in mind as we go. So having seen this, we can write half reactions. And so there are 2 half reactions, the half reactions for the copper, what's happening to the copper ion, and what's happening to the chloride ion. So we've split out the completed reaction, and we've just written it in a more formal way. What's happening here is the copper 2+ ions are gaining electrons. So recognize that must be a gain of electrons is a reduction reaction. And over here, the chloride ions are losing electrons. They're producing electrons. In that sense, they are donating electrons. This is the oxidation reaction. And remember, wherever there's the oxidation reaction, the initial substance, the reactant, is going to be a reducing agent. And over here, where reduction has taken place, the copper 2+ ions is going to be the oxidizing agent because it's taking electrons, whereas the chloride ion is donating electrons, and we remember it with OH-Rad. Okay, so that's very clear that there is a redox reaction taking place. Have a look. which electrode do you think then is the anode? Well, remember very clearly, we said when we want to find the anode, we have to look for an ox. An ox where oxidation is taking place. And we've just pointed out where oxidation takes place. Look over there. It's where the chlorine gas is going to be given off. So if you ask me which is the anode, that's the anode over there. And if we want to find the cathode, it will be the opposite one. And the reason, because this is oxidation and this is reduction. So we record it over here, and we can see that this is where we're getting the transfer of electrons, and we've indicated the production of copper is happening at the cathode, and the chlorine is being produced at the anode. So what does this tell us about the movement of electrons as they pass through this completed circuit? Let's have a very careful look at this, because it is important to know. So at the anode, notice this is a closed circuit. At the anode, we've got electrons that are being lost, because this is oxidation. And this electrode, we're finding that we've got the reaction of chloride ions are losing electrons to form chlorine gas, and those are the electrons that are picked up there. So in the solution, there's an interaction. The chloride ion comes along here, and it sees that there are lots of electrons. There's a positive, this is connected to the positive terminal. It wants to donate those electrons. The electrons get donated onto the graphite conductor. So electrons get pushed through here. They're drawn to the positive. So all the way along here, we get electrons moving in this direction, all the way around to the positive terminal of the battery. So the interaction here is the chloride ions are forming these chlorine gas bubbles, and we've recognized they've jumped on, they form the gas bubbles, and they bubble to the surface. They're being pulled as negative ions, they're being pulled to the positive terminal of the electrode. So we know opposites attract. Negative ions pull towards the positives. And I want you to notice something else. The chloride ion is an anode. Is an anion. So chloride ion is an anion. It gets pulled towards the anode. So that's how we know that we were right in saying this is the anode where oxidation is taking place. Now, what happens on the other end of the circuit? Well, the other end of the circuit, the electrons are still going to be pushed through here. The circuit is complete because we've got an electrolyte, and I want us to see that this graphite conductor has become a negative plate. So the electrons are being pushed all the way along there. It becomes negative. Lots and lots of negative charges. Now, just to make it slightly easier for you to see, I'm going to change the color of the ion. And I'm going to say we've got some copper 2+ ions in the solution, and they've been swimming around in solution. They're happy to muddle around. And now suddenly, it's like putting a magnet into the solution. You've turned on the plate, and there are negatives sitting on the plate. They're going to want to grab those electrons. They're wanting to jump and gain the electrons. And in that process, they're taking the electrons. And if they gain electrons, they're undergoing reduction. And the reaction we're going to see there is copper 2+ ions. They gain 2 electrons to form copper, which we can clearly see as a solid on the plate. So over here, they jump onto there. They're going to gain that electron. And that means that more electrons can get deposited on the plate because more and more copper is being deposited. And slowly the color of the solution gets paler. This one would have been much darker before we started. all those ions get taken up, they get produced and labeled onto the plate, and we see a complete process of the movement of ions. So in the circuit over here, even if we had a chloride ion sitting over here, notice what the movement of the negative charges is going to be. Anything that's negative is going to move in that way. So the negative ions move from wherever they are in the direction towards the anode, then through the wires, through the wire over here, around through the battery, and so we've got a complete circuit. And that's the important thing. Now, we could trace the movement of positive ions in exactly the same way. I'm going to use the blue color to show that. And you will see that the copper ions, where they were sitting over here, they're going to move towards the negative electrode. And inside the wires, positive charges, if they could move, would be moving in this direction. They would move towards the negative terminal of the battery. From the positive terminal of the battery, we've got positive charges. They're not actually moving, but as if they were moving. And that blue line then represents conventional current. And so you need to understand, if negative ions move in one direction, positive ions will move in the other direction. But we've got the movement of charge because it's a closed circuit. So just make sure that you understand, as we look at the electrolytic cell, that we've identified that there is a redox reaction happening. Yes, we know that. And we recognize that at the anode, there is oxidation taking place. At the cathode, there is reduction taking place. But there is something slightly different to the galvanic cell, which was exactly the same in the sense that the anode was oxidation and this was reduction. But in the galvanic cell, this was the negative electrode and this one was the positive electrode. But in the electrolytic cell, the anode is where oxidation takes place, but it's the positive cell. And this one, where reduction takes place, it's the negative electrode. Just check that out. And you can see exactly what we've done there. We've said that this was where was the positive, and this was the negative. So that's the difference when we look at the galvanic cell and the electrolytic cell. This one being positive, this one being negative. And in fact, I say to learners, don't learn it as positive and negative, just learn it at where oxidation takes place and where reduction takes place.